right, so in this video, we are going to review not only the stoichiometry that we just practiced in our notes in our worksheet, but then also just rewriting and reviewing how to write chemical reactions. All right, so we've got two problems here. The first one tells me to consider the reaction between zinc and hydrochloric acid. So here's a quick review of our chemical reactions here. I've got zinc reacting with hydrochloric acid, which is HCl. Notice this is going to be a single replacement reaction. And so what I'm going to need to do, zinc is going to go in, and because when it is an ion, it has a positive charge, it is going to kick hydrogen out. So zinc will form a new compound with chlorine, and I'm assuming the reaction is going to occur and that I don't need to check my activity series. So remember, zinc has a 2+ charge, okay? Chlorine has a 1- charge, and so what's going to form for zinc chloride is the formula ZnCl2. Do keep in mind, since hydrogen was kicked out, it is now going to be by itself, but because it is a diatomic element, it can't actually exist by itself, so it's going to exist as H2. Now I've got 2 chlorines here, 2 hydrogens here, so I'm going to put a 2 in front of HCl, and there's my lovely balanced reaction. And it's really important to make sure it's balanced because we're about to do some stoichiometry with that. All right, for B, it says calculate the moles of HCl, my reactant, needed to react completely with 8.25 moles of zinc. So here's our first stoichiometry problem here. My given is 8.25 moles of zinc. Okay, and I need to get out of moles of zinc, and notice I'm going to write moles of Zn because you've got to be really clear what you're in and what you're getting into now because we're going to have moles of different substances. So I'm going to get out of moles of zinc by putting it on the bottom, and I'm going to get into moles of hydrochloric acid by putting moles of hydrochloric acid on the top. And remember here, this is the new concept for stoichiometry, the mole-to-mole ratio. The mole-to-mole ratio, those values, that relationship you get from your balanced reaction by looking at the coefficients. So the coefficient for HCl is a 2, so that's what I'm going to put in front of HCl. The coefficient in front of zinc is a 1, since there isn't anything there. All right, and so what I'm going to need to do is I need to take 8.25 and I need to multiply that by 2, and I get 16.5. All right, really quickly figuring out sig figs. 8.25 has 1, 2, 3 sig figs. 16.5 actually already has 3 sig figs. My units are going to be moles of HCl, or just moles, that's okay. And that is my final answer. All right, let's look at C. It says calculate the grams of zinc chloride produced if 0.238 grams of zinc react completely. So if my given is 0.238 grams of zinc, I want to know how many grams of zinc chloride are going to be produced. So I'm going to start with my given, and this is going to be a multi-step problem, so really making sure that you're showing your units and what happens with your units is really important here. So I've got 0.238 grams of zinc. All right, in order to get into any terms of zinc chloride, however, I need to first get into moles of zinc so I can use a mole-to-mole ratio. So I want to get out of grams of zinc, and I want to get into moles of zinc, so I'm going to put moles of zinc on top. All right, now that I'm in moles of zinc, I can get into terms of zinc chloride by using a mole-to-mole ratio. So I'm going to get out of moles of zinc, and I'm going to put moles of zinc chloride on the top. So now I'm in moles of zinc chloride, which is wonderful, except I don't want to be in moles of zinc chloride. It's asking me about grams of zinc chloride, so it's going to be one more step. I'm going to put moles of zinc chloride on the bottom, okay, and I'm going to put grams of zinc chloride up top. So notice the amount of detail that I'm providing for each of these steps. Okay, if I can do it, I know you can do it. All right, grams to moles, that is my molar mass. So I need to look at zinc, and zinc's molar mass is 65.38. So that's going to go in front of grams because that is my molar mass, 65.38 grams for every 1 mole of zinc. Then for this mole-to-mole here, that's going to be my coefficient. So I look back, the coefficient in front of zinc and zinc chloride is a 1. Okay, that doesn't mean you can just skip that step, even if you know it's going to be a 1-to-1. Okay, we're still going to show that relationship. Then I need to determine the molar mass of zinc chloride. So the molar mass of zinc is 65.38. Okay, the molar mass of chlorine is 35.45. 3 or 4.5 is totally fine, times 2. And I get 136.268. And that's going to go on top now because the grams are on top. Okay. So 136.286 is my molar mass all over 1 mole. So what I'm going to do to find my answer now, I'm going to take my 0.238 and I'm going to divide that by 65.38, and then I'm going to multiply by the molar mass of zinc chloride, and I get 0.4961. Okay, keep in mind, and I rounded a tiny bit, but I know how many sig figs I need. Keep in mind you need 1, 2, 3 sig figs. This 0 does not count because you're counting left to right, and you can't start counting on a 0. So I'm going to just keep these 3 sig figs here, so 0.496, and your units for this problem are going to be grams. All right, so what that tells me is if I start with 0.238 grams of zinc and all of it is used up and we have an ideal situation, what will be produced is 0.496 grams of zinc chloride. All right, let's look at a new reaction and some new stoichiometry. I'm told I have lead 2 nitrate and it reacts with potassium iodide. I know this is going to be a double replacement reaction because I'm switching partners, but I need to determine the formula of lead 2 nitrate and of potassium iodide. So lead 2 nitrate, I know the charge of lead, it tells me it's 2+. I know the charge of nitrate is NO3 with a -1 charge. So the formula for this is going to be PbNO32, okay? Potassium iodide, potassium has a 1+ charge. Iodide has a 1- charge. All right, so when I cross my charges, I simply get Ki. Remember, for a double replacement reaction, innies and outies. So it's not potassium, lead is going to form a new compound with iodide, right? Those are my outies, and then potassium with nitrate. Well, lead, as we just noted, has a 2+ charge. Okay, iodide has a 1- charge. So when I cross my charges here, I end up getting PbI2. Then I'm going to cross potassium, which has a +1 charge, with my nitrate, which has a 1- charge, and I get KNO3. The last thing I need to do, which is very important when I'm doing a stoichiometry problem, is I need to balance. I've got 2 nitrates here, I've got 1 nitrate here, so I need to put a 2 here. That gives me 2 potassiums there, so I need to put a 2 in front here on my reactant side. Then I have 2 iodides on my reactant side, 2 iodides on my product side, 1 lead on my reactant, 1 lead on my product, and I am balanced. All right. For B, it says calculate the grams of lead 2 iodide that can be produced from 5.00 moles of potassium iodide. So I'm going to write out my given here. I start with 5.00 moles of potassium iodide, and I want to get into grams of lead iodide. All right, so the first thing I need to do, I'm already in moles, which is awesome. I don't have to convert into moles of potassium iodide. So I want to get out of moles of potassium iodide, and I need to get into moles of lead iodide. All right, so I'm going to put moles of potassium iodide on the bottom to get out of them, and then I'm going to put moles of lead iodide on the top. Awesome. Now I'm in moles of lead iodide, which is wonderful, except I don't want to stay there. I need to get into grams. So I'm going to put moles of lead iodide on the bottom, and I'm going to put grams of lead iodide up top. All right. Now all I have to do is plug in my values. So the mole to mole ratio here, I just wrote out my balanced equation. So the coefficient in front of lead iodide is a 1. The coefficient in front of potassium iodide is a 2. Now I need to determine the molar mass of lead iodide. The molar mass of lead is 207.2. Then I'm going to add to that the molar mass of iodide, which is 126.904, but I need to multiply that by 2 since I have 2 iodides. And the molar mass of lead iodide, which I'm going to put in front of the grams up top, is 461.008 grams over 1 mole. So I'm going to take my 5, I'm going to divide by my 2, and then I'm going to multiply by the 461, and I get 1,152.5 grams. Note 5.00 has 3 sig figs, so 1, 2, 3 for my final answer. That does not round that up, so it's going to be 1,150 grams. Or if you want to put this into scientific notation, you would move your decimal place over 3 places, 1, 2, 3, and you would get 1.15 times 10 to the 3rd grams. Either answer is perfectly fine. All right, for the last one, it asked me to calculate the grams of lead iodide that can be produced from 75 grams of potassium iodide. All right, so here, instead of being in moles of potassium iodide, I am in grams. So I'm going to start with my 75.00 grams of potassium iodide. I'm going to get out of grams of potassium iodide by putting it on the bottom, okay? And I'm going to get into moles of potassium iodide because I want to be able to get into moles of lead iodide. So I first have to put moles of potassium iodide on the top. Then I'm going to get out of moles of potassium iodide, and I'm going to get into moles of lead iodide. Okay, so moles of Pb. And what you should notice is this is very similar / now at this point identical to what we did up right above in the previous problem. I want to get out of moles of lead iodide, okay, because it's asking me to get into grams. So I'm going to put grams on the top. Okay, so grams of lead iodide. All right, now let's plug and chug. I actually know most of these values. This is a 1:2 ratio. That's what I did right above here. I know the molar mass of PbI2. I just determined it right above, 461.008 grams for every 1 mole. Sorry, my handwriting's getting bad. And now I just need to determine the molar mass of potassium iodide. The molar mass of potassium is 39.098. The molar mass of iodide is 126.904. And so what you end up getting for the molar mass, which I'm going to put on the bottom, is 166.002 grams for every 1 mole. So I'm going to take 75 and I'm going to divide it by the molar mass, divide by 2, and then I'm going to multiply by the molar mass of potassium iodide, which is 461.008, and I end up getting 104.14, 104.142. Now I need to figure out my sig figs. Notice 75.0, I'm going to count from left to right, 1, 2, 3, 4 sig figs. So my final answer here is going to be 104.1, and my units are grams.